NVIDIA's DGX Spark is one of the most interesting pieces of hardware I've seen in a while. It's a first-gen product, but it's from the most valuable company in the world. It's designed to be entry-level, but it's a $4,000 mini PC, got 200 gig networking, and it's freaking gold, and the front kind of looks like a sponge. Right away, let's talk about the specs here. We get the NVIDIA GB10, an SoC designed for a desktop form factor AI workstation featuring 20 ARM CPU cores and the Blackwell GPU with 5th gen tensor cores. Along with that, we get 128 gigabytes of LPDDR5X shared memory, a 4 terabyte NVMe drive, dual 200 gig networking ports, and it runs NVIDIA's custom DGX OS based on Ubuntu. It's got a TDP of 140 watts and it's $4,000. In this video, we're going to be trying it out as a self-hosted LLM inference server against other devices in the same product stack to answer two questions. Who is this for and is it worth the price? Now, right away, let me admit to you that I am not an expert on AI. I know just enough to talk about it over a few beers, but for in-depth tests and reviews, go watch some of the other people who are way smarter than me. So the first thing I had to do for this video to exist was actually get my hands on a DGX Spark. And any ideas on where I could do that?
Yep, of course, Micro Center. And shockingly, they have an actual DGX Spark in here that you can actually play with. So they have the DGX OS that we'll be looking more at later when we get home. I don't know where in the video this actually is, so maybe we did look at it already. I don't know, terrible YouTuber. But they also have it running Comfy UI. But the cool thing is here is that they have it in stock. It is $4,000, I'm sure we discussed that as well. This is a very unique product. It's not so unique that there aren't other options. It is a ARM system, so it's 20 cores, I think 10 on the CPU, 10 on the GPU. It's got 128 gigs of RAM for larger models, and it runs NVIDIA's ecosystem, which is kind of what makes it unique. But it's not, like I said, so unique that there aren't other comparisons. At home, I have a couple of options, and here at Micro Center, they also have a couple of other options for AI, specifically the big one, the one that's going to be the most apples to apples comparison to the DGX Spark is AMD's, let me see if I can get this right, AMD's Ryzen AI Max Plus 395. It's comparable in that they both have 128 gigs of integrated VRAM. I have a system at home with that. We're going to go check out one over there as well. But they're going to be very similar. Then you have a big boy system, like an RTX 5090 workstation, which would be way more expensive. And we will test that because I do have one at home that I use for editing. And then the cheaper option that a lot of people have been made aware of with the surgence in OpenClaw, the Mac Mini. So let's, I guess, go look at some of the other options. So yeah, oddly enough, the DGX Spark falls into, I would say, the mini PC category, which Micro Center does have, and like I alluded to before, there is one with the, let's see, did I get it right? Ryzen AI Max Plus 395. I think that's what I said. Awesome. Over $1,000 cheaper. You do get a little bit less storage, NVMe storage on it, but this thing, this chip is going to be, I think, very comparable to what's running in the Spark. If you're not too spooked out by Apple, I think, yes, there's actually multiple options from Apple. I'll be testing out specifically on the M4 Mac Mini, which is only $500. And I'm testing this out not specifically because I already have one and I'm too cheap to buy the Mac Studio, which I think, well, it should for the price. We're talking like $3,600, or if you want to go with the big boy, over $5,000 would perform probably better. But I kind of wanted to see from a cheap perspective, an apples to apples perspective, and we're going to check out my RTX 5090 setup, which would be the expensive option. See how it stacks up. My personal hypothesis is that it's going to perform okay compared to the AMD, the Ryzen chip. I think it's going to be a wash, but you know, I've been wrong before. It's happened. I know, crazy, right? So let's see. Let's test them.
Okay, so for testing, I wanted to test the Spark in a vacuum. Like, how does it perform on its own without comparing it to anything else first? Like, how's the operating system? Does the performance back up the claims? And how are the thermals? The whole thing with the Spark is that it's technically supposed to be an entry-level device, but for AI developers who are building things to scale into systems that cost hundreds of thousands of dollars. So when they can get a system that can hold some pretty decent sized models, utilize CUDA and tensor cores, NVIDIA's architecture, and can link to another device over 100 gig networking, $4,000 is a pretty good deal. For the rest of us, that's a shit ton of money. For what it is, it performs pretty well. With 128 gigabytes of shared memory, we can load in some big ol' 120 billion parameter models, and the speed of the RAM is, well, it's okay. The bandwidth, or how fast we can feed data to the GPU for processing, is 273 gigabytes per second, which may sound like a large number, and it is, but it's far from being anything crazy when it comes to other, often more expensive options. I've read some reviews that mention thermal throttling, and it wouldn't surprise me cramming this much power into this tiny of a form factor, but with my workloads, which consisted primarily around LLM inference, I didn't really see any. I'm sure under sustained session with crazy high context lengths or during model training, it can happen, but if you're just using the Spark to run some LLMs, you're probably fine. You may have noticed that the Spark's networking is actually a Connect X7 with 2 ports sharing a 200 gigabit connection, which, I mean, if you buy that card by itself, it's like a $2,000 part. Would I rather them take off $2,000 of the price and just stick me with the 10 gig? Probably. Now, like I mentioned, the Spark comes pre-installed with DGX OS, which is based on Ubuntu and has all the NVIDIA toolkits and drivers preloaded so you can hit the ground running. There's a little dashboard which shows some statistics and has some links to guides or playbooks to get things running like Ollama, training models, vibe coding, all kinds of stuff. For developers and tinkers, this is kind of a double-edged sword. On one hand, it's nice having all the necessary drivers and how-to guides loaded on here so everything is ready right when you get it out of the box. On the other hand, some people would probably prefer to have their own environment with their own dedicated software of choice, but that's what you get. I want to reserve a deep dive into the software for a future video because I think it deserves it, but also this video was really to see, is it worth it compared to other options? So we brought in a few opponents here. We've got the M4 Mac Mini, a B-Link mini PC housing an AMD Ryzen AI Max Plus 395 or Strix Halo chip, and my main workstation, which is kind of over there, kind of in my 42U rack down in the garage, so not bringing that up, but that houses an RTX 5090. So to test these 4 devices against each other, we're going to have to discuss a few terms: prefill and decode, which roughly translates to prompt processing, and token generation, which even more roughly translates to processing what the user is asking and then responding to the user. When performing the test that we are, which is basically how quickly it can perform these tasks with different size models, there are 2 important factors: how much raw processing power your GPU has, which will affect the prefill step, and how fast your memory is, or your VRAM bandwidth. This will be for the decode. Then, of course, the amount of memory you have will determine the size model you can run. If we look at each of our test subjects, they each have different strengths and weaknesses in that regard. The DGX Spark has a lot of memory at a decent speed with a moderate level of compute power, but it has NVIDIA's tensor cores, which can enhance certain tasks like prefill and training. Then you have something like the M4 Mac Mini that isn't great across the board, but it's by far the cheapest option. The Strix Halo is probably the most direct comparison to the Spark, with very similar specs outside of the GPU being a bit more powerful but not having NVIDIA's tensor cores. Then we have the RTX 5090 workstation, which you can see has insanely fast memory, but not too much of it. And it's going to be the most expensive when we're talking about a full build. So yeah, let's talk about the test. I had AI help me write a script that would run the same test on each of these machines, which will run some LLM inference on 5 models: Qwen 3.8b, 14b, 32b, Qwen 2.5 72b, and then GPT OSS 122b. This test will help us determine a few things: how fast can we process the prompt, how fast we can respond to that prompt, and how large of a model can we actually run. Let's take a look at the results. First, we're going to look at the prefill, or how quickly we can process the prompt in tokens per second. It's pretty clear that with the first few models, the RTX 5090 is just smacking the others around, which makes sense. However, when we get to the 72B model, the DGX Spark is actually the fastest, and the Strix Halo and 5090 are basically tied below that. And we see a similar pattern on the GPT OSS 120B model. Let me explain what's going on here. For the models 32B and below, those are small enough to fit the entire model in the 5090's 32 gigabytes of VRAM. However, the 72B model has to be split between VRAM and system RAM for the larger ones, which greatly affects the performance. As to why you're seeing higher numbers on the 120B model, well, that's because it's a different architecture, so different quantization, different numbers of active parameters, but that's beyond the scope of this video. I removed the 5090 from the graphs just so you could see the others compared a bit easier, and you're definitely seeing the limitation of the 16 gigabytes of memory on that M4 Mac Mini, since we can only run the 8B and 14B models. As for the Spark edging out the Strix Halo, that's not surprising considering NVIDIA has always had the leg up when it comes to specific AI tasks with their GPU and Tensor cores. Now let's move on to our decode tests, or how quickly we can generate a response. Looks a bit similar, right? The RTX kills it for the first three models, then falls off after that when it has to load some of the model into system memory. But this time you may notice that the Ryzen AI Max Plus 395 is just slightly outperforming the Spark across the board. Why? Doesn't the Spark have slightly faster memory bandwidth? Yes, but while memory bandwidth is the main driver for decode, it's not everything. You still need the GPU to do some of the work, so even though the DGX Spark and AMD's Strix Halo chip have almost identical memory bandwidth, the Strix Halo has a larger GPU that can hide memory latency better and run more compute in parallel, which is why it can sometimes generate tokens faster. Again, removing the 5090 can show us just how close these two really are, and again, the M4 Mac Mini brings it up the rear, but that was always going to be the case. I did also want to show these same results in words per second rather than tokens, because I think that gives you a better grasp on how fast these devices are actually working. Like, look at the 5090 on the 8B model. 157 words per second is wild. And 8B isn't exactly the tiniest model around. I think 14B is more of the sweet spot for the other machines, where it's fast enough for most tasks, but once we get over that, things are a bit different. For Qwen 3 32B, the RTX 5090 workstation is the only usable device, and nothing runs the 72B well at all. Like we saw before, the GPT OSS 120B model can run on everything except the Mac Mini, and since the Strix Halo and the Spark can fit the entire model into VRAM, they both perform pretty well. But now I want to show a fun chart, tokens per watt during decode. Here is where the Mac Mini gets to shine. While the Mac Mini wasn't the quickest, it was by far the most efficient, since it also uses much less power than the other devices. So maybe if you're looking for a super low powered device that can run some 8B models pretty well, the Mac Mini may actually be for you. Through this test, we could break down each device's strengths and weaknesses as they relate to the inference speed, the size model they can run, how power efficient they are, and the affordability. Like we just saw, the M4 Mac Mini isn't the fastest and can't run large models, but it's efficient and it's cheap. The DGX Spark can run some big models pretty fast, but it's expensive and not super efficient. The Strix Halo is very similar, except it's a bit more affordable, but a bit less efficient. Then the RTX 5090 is super expensive, but it's crazy fast for the models it can actually run, and surprisingly efficient. Which one of these you choose to go with will be determinant on your use case and what you're prioritizing, because as we just saw, each has their own place. Now let's see if we can answer the questions from earlier. Who is the NVIDIA DGX Spark for? Well, I think it's pretty clear it's for AI developers who are building tools that need to scale out to much larger systems, which in most cases is going to be on NVIDIA hardware. If you're building and training models that directly utilize Tensor cores and want to ensure that your build is directly transferable to larger systems that also use Tensor cores and has the same NVIDIA architecture, then it's a no-brainer. $4,000 is actually a drop in the bucket to have your developers have a functioning dev system running on their desktop. Now, what about the other 99% of people who just want a device to mess around with AI stuff? Well, the other three are going to be more in your wheelhouse. For the best all-around performer, it's pretty hard to argue against the AMD Strix Halo chip. It's faster than the Spark in a lot of decode tasks, and it's cheaper. Like, sure, you don't get the tensor cores or 200 gig networking, but those 99% of users don't care about that. And say if you already have a machine that you're looking to turn into an AI workstation, then you may actually consider getting an RTX 5090, especially if you're going to be training models. For those of you who just want to self-host some basic AI stuff, the Mac Mini is actually great. It's affordable, tiny, and it'll just vibe in the corner doing its thing using little to no power. But yeah, that's my high-end review of the DGX Spark, and like I mentioned, this is not a deep dive. Let me know what you think down in the comments, and if you liked the video, then drop a like and subscribe if you want to see more technical AI content. Not AI slop, we're gonna stay away from that. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my tiny AI mini PC with high-speed networking and super fast LLM inference. LLM? Y'all are the best. And if you're still watching, you're a T800. Thank you so much, and I'll see you in the next one.